I'm going to talk in this next section about the development of big ideas, the development of strategies, and the development of modeling. And I'm going to use multiplication as a topic to do that. When children first attack a problem that might call for the operation of multiplication, they often use a very inefficient strategy. We could call it counting. They may get something out, some kind of counter out, and they will represent the groups and every object in the group. And they will lay out all the cubes, counting the number in each group. They will count the number of groups, and then to get the answer, they go back and they count all over again from 1. So that's a real early strategy on the landscape. What children often do, they realize this becomes way too tedious, and they don't need to start doing all this counting, and they begin to skip count. And this, of course, leads to repeated addition. The two are really directly linked. They're seeing this as an additive type situation, and they start either skip counting or they write down all the repeated additions. So we see that the big idea evolving here is that they're beginning to understand that grouping is a critical way to think about this rather than thinking about it as single units. Another big idea directly linked here is that you can actually count the groups. Unitizing the groups as a unit that can be counted is huge. Just coming into view on the landscape, when children start trying to do all this repeated addition, which is very cumbersome. I mean, imagine 6 groups of 15. All right, so children either have to skip count by 15s, which isn't particularly easy for the normal 3rd grader, or they have to add up all the 15s, which isn't particularly that easy for the normal 3rd grader either. And so what do? They start regrouping the groups. As teachers, we've all seen them do that. They make these little carrots and they put 2 15s together and they call it a 30. And another 2 15s together and they call it a 30, and another 2 15s together and they call it a 30. It's a little bit easier to add 30 and 30 and 30 than it is to add 6 15s up. But isn't this interesting? Because regrouping the groups is a big idea. It's a new part-whole relation. I don't have to just make the groups of 15. I can regroup my groups and put 2 15s together and count those. They now have turned 6 groups of 15 into 3 groups of 30. And that's a far more powerful expression to substitute. Later, being able to just look at the bare numbers, 6 times 15, and say, hey, that's 3 times 30, I'm done, it's 90. That's powerful. So you're seeing a developmental pathway here. This leads to doubling and halving. Regrouping groups can also lead to partial products. When kids realize they can regroup the groups, they say, hey, I know 10 times. What if I were going to do 12 15s? Well, I could do 10 15s and 2 15s. Well, that's a whole lot nicer, isn't it, than doing all this repeated addition. And of course now, the partial product strategy is on the pathway to the standard algorithm. But you see, once again, the children, when they're inventing this, are using the bigger piece first, which is much smarter in terms of being able to keep track of where you are, than the standard algorithm, which pushes them to do, what did I say, 12 times 15, pushes them to do 2 times 5, 2 times 1, which is really 110, 1 times 5, which is really 10 times 5, 10 times 10, or 1 times 1. You got to add all these partial products up. It's very cumbersome, and children lose track of where they are. Also on the landscape, when children start thinking of doubling, well, I know that 1 15 is 15, so 2 15s would be double. Oh, I could go to 4 15s right away, because that would be double 2 15s. Oh, I could go to 8 15s right away, because that would be double 4 15s. I'm not skip counting any longer, I'm doubling. And this leads very nicely into a representation of a model on a ratio table, which I know high school teachers are saying, wow, if only elementary teachers would do that, because there's functions and linear functions, and the ratio table is being introduced. That's an important model for algebra. When children are doing partial products, it's very nice to start using an array to model it, because the array will show the partial products and will lead eventually to the algebra of, again, another example of the use of the distributive property, which is the big idea that partial products gets you to. The doubling and halving gets you to tripling and thirding, quadrupling and quartering. Really what you're doing is just associating a factor differently, and that leads to the associative property. This landscape that I'm talking about is the foundation for the development of algebra. And this is what we need to be focused on in the elementary school. It's not just isolated procedures.